All right, last video for the day. I also recorded this one and it didn't count, but now it looks like it's counting. Thank goodness. This is showing you how to use the table. This is a table help video. It's 3 topics we're covering. We're talking about z to a percent. That's all the table does. Take a z-score, change it to a percent. We're talking about taking a percent or a proportion and changing it back to a z-score. And we're talking about what happens if we need to find the area between 2 z-scores. So those 3 things are the things we're going to talk about. First thing first, z-score to a percent. Well, this finds the left side. So what this actually is finding, to take a z to a percent, thankfully it was kind enough to actually shade the left. I colored it all over with green. What we're doing is we're finding the percent of area such that our z-score is higher than it. So we start with a z-score. Let's say we start with 1.34. And we want to find what percent of data or area is less than that z-score. Keep in mind it only finds less than. It does not find the other half. To do the other half, we'll talk about that in a minute. So 1.34 is the z-score. So notice in our table, I'm using this one because it's the positive z's. We have z-scores on the outside, and the inside it's percents. So I'm looking, I know my z-score, it's 1.34. So I'm actually going to find 1.3 and the 4, because that's 1.34. We're going to play Battleship. And I'll make weird clicking noises. 0.9099 is the area. 0.9099. That's the area to the left of my z-score. I could also write that as a percent, 90.99%. Those things are both true. So the area is the proportion. Percent is just, I only use percent if they ask for it. Otherwise, just leave it as a decimal. Now, to answer the other side, what if I wanted to know the percent that was greater than my z-score? I still have to find this pink area. But if I'm looking for green, well, I know that the whole area of a normal curve is, of any density curve is 1. So if I just subtract out 1 minus 0.9099, if I have the whole thing, 1, and I subtract out the part I know, then I get the part I don't know. So that's how you find the upper. If you need it, you just find the lower first, minus it from 1. Life's good. Okay, so then the second thing we're going to talk about is the area between 2 z-scores. So like, say I have two data points and I want to find what's the probability or percent of scores that are in between those. Well, that's where you would have to actually turn both of those points into z-scores. I'll call one z1 and I'll call another one z2. Say I'm looking for the area between z1 and z2. Well, you just use the table to find the area left of z1, call it green, and then you find the area left of z2, which covers all that, green plus the middle, and you do a little subtraction. You do the left of z2, the pink, minus the green. Because if you think about it, if you tap the big part, that's the left of z2, and then you just subtract away the green, what are you left with? The middle. So that's cool. So that's the between stuff. And then the last thing I'm going to show you is taking a, if you start with a percent and you're going back to a z-score. This happens sometimes if you want to know like what percentile, what score you need to be in like the top 10%, or what score you need to be at the 87th percentile. This could work for those types of problems. So what you do, let's just, so it would be a situation like this. Say I wanted to be in at the 60th percentile. That means 60% or lower than me. I'm looking for a z-score that falls exactly higher than 60% of the data. This table can do that too. We just have to go reverse. So I just look in the middle, because the middle is the percent section. So I look, okay, where is that 60%? Gonna find it in here. It looks like this side's the big half. 60%'s up here. It's between those two. It looks like the 5987 is a little closer to 60%. It's just a smidge. And then you can just backward z-score. You backward battleship to find your z-score. So you start with the middle and you go zoom to the outsides. It's 0.25. So this z-score is 0.25, which makes sense. It's just a little above 0, which is in the middle. All right, thanks. Hopefully this recorded unlike last time. Have a good one, everybody.